In this video, we're going to begin to look at a really important problem-solving technique known as recursion. We've already seen that one function can call another function. In recursion, a function calls itself. So here, for example, I have a function for computing the factorial of a number n. And you can see we start by checking to see if n is less than or equal to 1, in which case we return 1. The factorial of 0 is defined to be 1, and the factorial of 1 is also 1, so that's the appropriate thing to return in those cases. Negative numbers are also going to get grouped into this case, but we don't need to worry about that. Otherwise, if we don't have a value that's less than or equal to 1, we're going to return the value of n times the result of this function call. And notice we're calling the function itself, but with a different input. Instead of n, we have an input of n minus 1. And so this fac function is calling itself to do part of the work. And that's at the heart of recursion. And the idea here is that the function is taking the original problem, which is computing the factorial of n, and reducing it to a simpler or smaller problem of the same kind, which in this case is computing the factorial of n minus 1. And then once we have the solution to that smaller problem, we can use that to solve the larger problem by multiplying the result of fac n minus 1 by n. And what we're doing here is taking advantage of the fact that the problem has what is sometimes called recursive substructure. We can define the problem in terms of itself. So mathematically, the factorial of n is n times the factorial of n minus 1. And that's why we're able to use recursion to solve it. Now, what's going to happen is we're going to get a whole sequence of recursive calls. For example, if we started with an input of 5, fac 5 would call fac 4, which would call fac 3, etc. And so we're going to get a whole sequence until eventually we get down to that case in which n is 1. That case is known as the base case. And that's the place where we actually stop the recursion. And it's really important to have a base case because otherwise you would keep calling the function repeatedly. And that base case is the problem that is small enough or simple enough that we can solve it directly, in this case by just returning 1. We typically start a recursive function by checking for the base case, which is what we're doing here with this if condition. And if you have the base case, you go ahead and handle it and you don't make a recursive call. But if you don't have the base case yet, then you go and execute what is called the recursive case, which involves making at least one recursive call, one call to the function itself. Now it's possible to have more than one recursive call. It's also possible to have different base cases, different recursive cases. We'll see that later on in the semester. But for now, the basic structure is check for the base case. If you have it, go ahead and handle it. Otherwise, execute the recursive case in which you reduce the problem and make a recursive call to solve it. Now in this particular method, you can see that the recursive call is happening as part of a return statement. That's perfectly okay to do, but it turns out it's sometimes easier to take an alternative approach. Rather than making the recursive call in the return statement, we make it here. We assign the result of the recursive call to a variable, which in this case I'm calling rest, and then we use that variable as part of the return statement. It's equivalent to what we did before, but it often can make your job easier when it comes to writing a recursive function. Structuring your code in this way will also make your recursive functions easier to trace and to debug, and so we highly recommend that you take this approach. Rather than making a recursive call in a return statement, make it outside of that return, store the result in a variable, and then use that variable in whatever way makes sense. To see how recursion works, let's use our fac function from within the Python Tutor visualizer. So I've copied it in here. I still need to add a little bit of code here that will actually call it. And I'm going to do it like this. result is assigned the result of calling fac5, and then print that result. Okay, let's step through it. We define our function, and then we go ahead and make the first call. So see how we have a stack frame for fac in which the parameter n is 5, because that's what we passed in down here in the initial call. So we start by checking to see if we have the base case. We don't, so we skip down to the else block, the false block. This is our recursive case, and we make this recursive call. And notice we're going to be passing in n minus 1, or 4, and sure enough, we get another stack frame for fac in which n is 4. So these are two separate calls of the function. And remember, each function call gets its own stack frame. So now we execute that function, and notice every time you make a recursive call, the function starts over at the beginning, just like any other function call would. You always start a function call at the beginning of the function. And now we have n is 4. That still is not our base case, so we come down and we make a recursive call in which we pass in 4 minus 1, or 3. And so here's the stack frame for that call. We start the function over. 3 is not less than or equal to 1, so we come down and make another recursive call, passing in 3 minus 1, or 2. And we get another stack frame. We start the function over. We still don't have our base case. We come down and make a recursive call, passing in 2 minus 1, or 1. And so at this point you can see we have 5 different stack frames for our recursive function. And finally, now that we are at the point in which we have a value of 1 for n, when we come down here and check for the base case, we do have it. N is 1 here. And so we're just going to return 1. And so you can see down here the return value is getting ready to be returned. Now, where do we go back to? Well, we go back to where that recursive call was made. And so we're going to be coming back to here, but in the previous call in which n is 2. So watch what happens here. We click forward. The stack frame goes away. We're now back here in the call in which n is 2, and notice what's happened. You can see that the result of fac1 has been stored in the variable rest. And so rest here in this stack frame is 1. We then return the current value of n, which is 2, times rest, which is 1. So we end up returning 2 times 1, or 2, and that gets sent back to the previous call in which n is 3. And notice that its rest is assigned the result of fac2, which is 2. And then it returns its value of n, 3, times rest, 2, or 6. And that gets sent back to the previous call. So we keep doing this, and you'll notice that the return values are being sent back, and our ultimate result is formed on the way back from the base case. So this value of rest is 6, which is the result of fac3. We then multiply the 6 by 4 to get 24. It gets sent back to the original call and is assigned to its rest variable. Then we take its value of n, which is 5, multiply it by 24 to get 120, and that gets sent back to the global scope. That is our ultimate result, and that is indeed the factorial of 5. We then print that result, and you can see it's down here as our program output.